Will future houses be built of wood, steel, or even plastic? In connection with the Swiss Bau Fair in Basel in February 1999, a specific and very exciting suggestion was made as to how our homes will perhaps look in the future. This is a unique building under construction here, the Eyecatcher. This will be a spectacle, the mainstay of which is a plastic-based composite, a future building material for future needs. The contemporary demands are flexibility and mobility, and therefore we need concepts and materials that can be put together and taken apart like a building kit, and by this means create a new architecture that is both personal and covers requirements. 140 innovative Swiss companies and higher educational institutions are financing and constructing the building. This means 140 contributions of actual, specific know-how about the science of construction, house building, energy and synthetic materials. A pilot project that leads to architecture that, with lesser usage of materials and energy, brings about more prosperity and flexibility. For this, we are using materials that meet the demand of being easier to handle and, at the same time, fulfill as many functions as possible. In other words, multifunctional. Take a plastic-based composite. This material has many of these properties, and all the possibilities have not yet been explored. With trial projects like Eyecatcher, we have only seen some of the many possibilities of the material. The future will show what all the possibilities can lead to. Plastic-based composites have already been standard in the car and engineering industries for decades. But a plastic-based composite as the load-bearing construction in a 5-story building, this is unique in Europe. So what are the advantages with this new building material? Plastic-based composites have a low weight and are therefore easy to handle on a building site. They can stand the greatest loads, are heat insulating, and are not attacked by rust. For the architect and engineer, plastic-based composites are the building materials of the future. These new materials have made possible a completely new integrated building method where one can assemble very different functions in individual building elements such as the load-bearing construction, insulating properties and energy supply functions. All this is not possible with steel and concrete. A year ago there was a premiere in Switzerland. In Pontresina, Switzerland's first plastic-based composite bridge was erected. This can be used in the winter months by pedestrians and skiers. In the spring, it's removed again because of flooding, and this is no problem. Thanks to the low weight of the bridge, it can be taken down and re-erected in the course of only half a day. Engineers and architects from the Technical College in Zurich built the bridge in November 1997. The aim of this pioneer effort was to test and further develop a plastic-based composite as a building material. Methods and construction techniques still do not match the material. Until now, screws have been used and, with this bridge, for the first time, adhesive joints. The plastic-based composite profiles are produced in Denmark. The basic materials comprise polyester and glass fiber, and the profiles, in principle, are tailored so that they precisely conform to the assignment. A thin veil in the surface increases the resistance quality of the profiles. An innovative technology, but there are still many development assignments ahead. Here we can see the fibers that are the basis material. The material's qualities are actually similar to wood, but here they are simply pressed into a completely new form. On this side you can see a typical cross-section from steel, and the object with the research is really to develop suitable forms and construction methods for the new materials. The plastic-based composite as a building material is nowhere near fully developed. Therefore, there was great suspense during the load tests at the Technical College in Zurich last summer. The test object was a beam comprising 3 profiles glued together. The ultimate question is whether the beam will react as one unit. Will the glued joints break? Or will the beam itself break? You can see here the eye profile we showed earlier. The break has occurred in the profile and not in the glued joint above. So, the joint is completely intact because the break occurred here in the profile itself. This is an important result because in Eyecatcher, the use of glue is the decisive step into the future. A first-class adhesive joins the lightweight standard profiles for a 15-meter-high load-bearing construction. This really is decisive new know-how. Never before have plastic-based composite profiles been glued together to this extent. No concerns have yet specialized themselves in this field, but in the Eyecatcher project, an innovative steel construction concern came forward. In the factory near Basel, there is a furnace available of sufficient size. Here, the adhesive surfaces can be hardened and controlled under ideal temperature conditions. An ultrasonic apparatus measures the quality of the adhesive joints. This method originates from steel construction, but ingenious specialists have transferred the method to plastic-based composite profiles. Eyecatcher is the symbol of enthusiasm for innovative thinking, a pilot project that tests the future, but in many ways, the future is already the past. Plastic-based composite materials are a good example of this because engineers are already moving away from steel profiles. New fascia units in plastic-based composites are, in fact, so strong that they can replace load-bearing profiles. This means that in the next Eyecatcher, even less materials will be used with even greater advantages.